This is Geometry, Chapter 10, Section 4, in which we will be studying inscribed angles. When we talk about an inscribed angle, what we're talking about is an angle where the vertex is on the circle and the two sides are chords of the circle. Or really, technically, we should say contain chords of the circle, because this angle CB or BCA doesn't just start at B, it actually goes beyond there. Okay. The intercepted arc of an angle, of an inscribed angle, is the arc that's in between the two chords. So for this angle, angle C is your inscribed angle. Arc AB is the intercepted arc. Okay. Which leads us to our first theorem of this section, Theorem 10.6, the inscribed angle theorem. If you have an angle inscribed in the circle, then the measure of that angle is equal to half of the intercepted arc. So angle C is half of arc AB. Or we could turn this around and say arc AB is twice as much as the angle. Okay. You'll hear me say this quite a bit when you're asking questions and so forth. If the angle is on the circle, then the angle is half the arc. You'll hear me say that over and over and over. The angle is half the arc. So let's do a little bit of work here with these. We're going to look for the length, or the measure of arc CF. And we know this angle, this inscribed angle at D, is 40. Well, if this inscribed angle at D is 40, the angle is half of the arc. Okay, the angle is half the arc. 40 is half of arc CF. And I really got a little sloppy there and didn't put my arc sign. But you'll forgive me. I'm sure of that. So then arc CF, boy, I really got sloppy there. Arc CF will equal 80. Okay. Suppose I need to find this measure of angle C here. Well, angle C, we could try to find it if you assumed these were perpendicular, but you can't make that assumption. So be careful there. Don't think, well, that's 40 and that's 90, so I can subtract and get the rest. But what we can do is we have angle C cutting off this arc of 98. Well, the angle is half the arc, so angle C is half of 98, which is 49. That tips me off that this isn't a right angle. Our next theorem tells me if I have two inscribed angles and they intercept the same arc, or they intercept congruent arcs, but really the same arc is what we're interested in, then the angles are congruent. What they're telling me here, angle P intercepts arc QR. Good grief, I can't believe I was that lazy. Angle P intercepts arc QR. Angle S also intercepts arc QR. Since they both have the same arc, that means the two angles have to be equal. And the same thing applies to angles R and Q. They both intercept this arc. So that means they are equal to each other. Well, we can do a little solving here. Subtract the x over, divide. Now we know what x is. And we need to plug that into angle R. Angle R is 3 times x. 3 times 8 is 24. Now we get to your favorite idea. They're back. They didn't go away. They just took a little vacation. Okay. So we get to do some proving here. And we'll start with a classic. We're going to try to prove some triangles congruent. This means we either need to prove that we have side, 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 or side, angle, side, or angle, side, angle. Something of that nature needs to be in play here. Okay. We know that arc QR is congruent to arc ST, and arc PQ is equal to arc PT. Okay. Now, since angle PQR cuts off this arc QR, I said PQR, I should have said QPR, that cuts off arc QR, and this other angle, SPT, cuts off this arc, and those two are equal. That means those two angles are equal. That's the theorem we just got, theorem 10.7. If they cut off congruent arcs, then the angles are congruent. Now we can say for sure that PQ is congruent to PT because arc PQ is equal to arc PT. That was a theorem from last time, 10.5. If the arcs are congruent, then their chords are congruent. Now we'll do a little bit of arc addition. Arc PQ plus arc QR makes arc PR. Right? P to Q plus Q to R makes PR. And the same thing down here, P to T plus T to S makes P to S. That's the arc addition postulate. Now, since those big arcs are equal, then their chords are equal. Well, first we have to say that the two arcs are equal by substitution. Then we can say that the two chords are equal. That's, again, theorem 10.5. And now we have side, angle, side. It gives us our congruent triangles. So we had to use the idea that the arcs were equal to get congruent angles. And also, arcs are equal give us congruent chords. Okay. Using a couple of theorems, one from today and one from previously. Put it together, and that gets us side, angle, side. There are probably other ways you could have gone there. Just, for future reference, there's always more than one way to get the job done. Okay. Our next theorem, 10.8, tells me that if I have an inscribed angle and it intercepts a diameter, it's a diameter here, MP, or it intercepts a semicircle, then that makes that a right angle. Okay, this is a variation of the angle is half the arc. If it's cutting off a semicircle, half of a circle is 180 degrees. The angle is half of that. Half of 180 is 90. Okay, this is just a variation on that same theme, that the angle is half the arc. So now our job is to figure out angle M based on knowing that that's a right angle and having information about M and P. Well, we know that the angles of a triangle make 180. So the first angle, M, plus the second angle, N, plus angle P equals 180. Cleaning up the arithmetic, subtract the 84 and do a little division, and now we know what X equals. Okay, knowing that x equals 4, now I can plug it back into angle M. 7 times 4 is 28, plus 2 is 30. Now we could figure out arc P, or angle P, if we wanted to. We could also figure out arc NP if we wanted to. But we don't want to right now. They didn't ask us to. One last theorem here. And the idea here is if we have a quadrilateral that's inscribed in a circle, then the opposite angles are supplementary. So in this case, X and Z would be supplementary. Y and W would be supplementary. And remember, supplementary adds up to 180. Okay, I'm going to give you a little hint about how to prove this because I have this funny feeling you're going to need to at some point. I don't know where these ideas come from. If we look at angle Y, it cuts off this big arc from X to Z. If we look at angle W, it cuts off the smaller arc from X to Z. Well, together, those two make a whole circle. These are each half of their arc. Together, they made 360, so together the angles would be half of 360, which is 180, which is supplementary. Okay. You might want to go back and play that part again when you get to that particular problem. Because, like I say, I just have this strange feeling you're going to need to prove this at some point down the road. So our job here is to find measure of angle Y and measure of angle Z. Well, we know Y and 60 together make 180 because they're supplementary. So that one was easy. We know X and Z together make 180 because they're supplementary. And subtracting that's pretty easy too. Okay. So more properties involved with arcs and angles, particularly in this case inscribed angles. Remember, when an angle is on the circle, the angle is half the arc. If you had questions along the way, hopefully you wrote those down. Bring them in with you, and then we will see you in class.